either the network that you're feeding to or a temporary key from maybe a third party who sent it to you. Once downloaded, it will ask certain permissions, the obvious being video, microphone, and sometimes location services, depending on what the use case is. If you notice in the app, there's a drop-down list on the top portion of the phone. From there, you can pick the channel either directed to you by the network or station, or it may be selected for you ahead of time. There are several different modes for your phone to transmit in. You can go live in store, store and forward, and store. On the top right corner, you'll notice the delay, video resolution, and a microphone icon. The delay is from your device to the server. This could be suggested by the network to you on what delay is best used. Once you've set that, whether that's 1080i, 720p, 60, you can go ahead and start from there. The other great thing about this app is that you can use your Bluetooth mic with the app. So likely the station will have IFB enabled so that they can speak to you and so that you can speak to them through the video. So you'll see on the bottom left corner a Wi-Fi and a phone symbol. You'll also see an Earth symbol. This indicates the overall bandwidth that you're streaming in. The phone will automatically use both network interfaces for optimal bandwidth during the stream. So you're probably wondering, why use LU Smart? Well, this is a great way for fans to stay engaged, for you to still leverage your control room resources, bringing in live, high-quality feeds. As you can see, I'm in an empty control room because most of my staff is at home, being safe, like every one of you are probably doing as well. So the great thing about this LU Smart app is you can still send feeds from your home back to your centralized control room, to your studio, to your production house, whatever that may be, but you can still keep in touch with people. So if you're interested, please see the link below. We have a URL that you can fill out a form to speak to a sales rep further about this product. We also have a quick guide as a setup to show you how this would work. I want to wish you guys all safety. Please stay responsible. Thank you for tuning in, and I hope to see you again.
Hey guys, James from LiveView here. Just wanted to give you a quick tour of my current at-home control room setup that we're using to produce our LiveView show completely remotely. And it all starts down here. So down here we have a LiveView quad server, a LiveView video return server, and also a Scarlett audio interface. The quad server allows us to receive 4 inputs from any LiveView encoder out in the field, whether that's the LiveView Smart app, the LU300, the LU600, any of those could feed back into this server, which then feeds into my switcher. Right above the LiveView quad server, we have the LiveView video return server, which does exactly what it says it does, video return. So if you're out in the field using the 600 and you're feeding your feed back to me, you can now see the program out of my switcher, so you can see when you're live on screen or what's coming up next. And right above the video return server, we have the Scarlett audio interface, which allows us to do things like IFB. Now IFB is important for this because we're producing the whole thing remotely, so it's good to be in constant communication with your talent or host or whoever's on the other end. Now moving up to the top of the table here, I have a Blackmagic ATEM switcher. It's a very basic switcher that allows me to do things like still images, lower thirds, picture-in-picture, things like that. Coming into the switcher are the 4 SDI inputs from the quad server down below, which allows me to see all 4 video feeds in the multi-view here. So for me to bring remote guests onto the show, it's super easy to do right through LU Central. I'll show you. So in my LiveView Central account, there's many ways to get new units into my inventory that I can use for the show. One being our new guest interview feature for the LiveView Smart app. To set that up, simply click on the guest interview button up top here. I can name my device. So in this case, I'll use my phone. You can choose the registration period, which is how long the link will be active for them. And you can choose the resolution. So in my case, 1080i 60. Next, you can send them the registration code via email or text message. So in this case, I'll just use my cell phone number here. And click on send SMS. So I just got the text from the guest interview feature. I'm going to click on the link here. And since I already have the Smart app installed, it's going to open directly on the camera. Now, back in Central, I'll be able to click on the device, set what channel I want to live stream to. So in my case, LiveView Studio 1 here. You can set the delay and start your stream. And I have my phone set right here. You can see it connects. And just like that, my feed is appearing in my switcher. And lastly, the program out of the Blackmagic switcher is feeding into our LiveView Solo here, which has 2 cellular modems and an Ethernet connection, bonding them together so you guys can watch this online live. I hope this gave you a little insight to how we're producing our show completely remotely. We hope to see you soon.
Good evening, everyone, and welcome to the LiveView Sports Show. My name is Chris Perry, coming to you live from my home studio here in Westborough, Massachusetts. Folks, we got a great show for you tonight, but honestly, this was a show that almost didn't happen. There was a lot going on. James, how did you weather the tropical storm this week?
It was pretty crazy, Chris. I'm not going to lie. My power did go off about 4 or 5 times, but it just flickered on and off. But I know for you it was a little bit of a different situation.
Yeah, so let's show our viewers what I had to deal with last night. There was a tree that came down just up the road here, wiped out not just 1, not 2, but 3 or almost 4 telephone poles. And we had no power here at the studio. Earlier today, I had to run my tease that was aired on Facebook. Actually did all of that off the generator. So this was a tough show to get on the air, but I'm glad to have all of you along with us tonight for what is going to be a great show, because tonight we're heading west to talk with Grand Canyon University. Tonight, Steve Nijelski joins me live here on the Sports Show. Good evening, Stephen.
Hey, good evening. How are you?
Great, thanks. So, Stephen, can you tell me a little bit about yourself and what you do with GCU?
Yeah, so I am a senior multimedia manager here, and that means I manage a team of amazing professionals that create content in a huge variety of different types. You know, we do a lot of live, we do a lot of pre-produced stuff, we do commercials, we do web, we do pretty much anything that you can put a video in, we've done it.
So, Steve, I know this is the sports show, but, you know, you guys did start with campus tours as sort of humble beginnings, heading towards a much larger vision of what you can do with live on campus. Can you explain what you guys were doing with campus tours and how that impacted students?
Yeah, we actually did start with other kinds of live production more broadly. You know, before we did the tours, we've been doing live events, live sports, going back 3 or 4 years now. But the live tour specifically was something that bubbled up through our admissions side, and they were doing them individually, you know, through a phone, on a gimbal, walking around, talking to prospective students. And it was really cool. They were doing those, a lot of them. They were booking a lot of them. So the idea is, I started talking to them about, hey, what could we do to really amp this up and to make it even bigger, even grander for a broader audience? And so that's where we actually did the first demo with the LiveView. Was we developed a show, essentially. It was about an hour-long live show, and there was a studio segment. There was a traveling, roving camera team with tour guides that went to, I think, a dozen different places on campus, and we kind of basically tossed back and forth between the studio, where they take Q&A from the viewers, then we'd go out to another segment, walk around campus, show them a new attraction, bounce it back. So it was this really fully broad campus experience that had a lot of interactivity and a lot of variety.
Stephen, that's really awesome. And so given the current state of the world, you know, where do you see this falling into the bigger picture, if you will, right? Because live is going to play, especially live streaming, is going to play an even larger part in your future, right?
Yeah, I mean, when you think about the vast number of events that take place on a college campus, and that's the main group that we work with is GCU, and all of the events that happen, you know, of course, they're generally built around the idea of a mass gathering of a lot of people in one place, and so that is going to be different this year. It already has been, But as we're heading into the fall, we're talking about a lot of ways to use live streaming to take experiences that used to be a lot of people on one place and distribute them out. So one of the examples is a weekly chapel service where there would be normally 5,000 to 7,000 people in the arena, and they're going to have to distribute that out and do a lot of that remote sites and individual streaming viewers. So it's in one of the big challenges that I'm sure everybody who's in my boat is thinking about is, well, normally when you build a live production, you have a large crew. It's a lot of people, and they're a lot of times are wedged in a little room, all breathing the same air, which we can't do anymore. So one of the things we've really been trying to think about is how to use more distributed crews and more mobile crews, and so that the live view and the ability to move around, the flexibility, the portability side of it, I think is going to be a huge factor, because so many of these events are no longer in a building that has great wired connections. They're going to be outdoors. They're going to be outside. And we have amazing weather in Arizona throughout the fall. It's a little hot in the summer, but right now, but in the fall it's great. And so we'll have all these events outside, and so really then all of a sudden you're like, oh man, how do we get connection out there? How do we get and the live view really answers a lot of that.
So this is the sports show, and you guys have done some sports productions. Can you talk about the pre-game shows that you guys have produced?
Yeah, definitely. Yeah, we do a lot of sports. We basically broadcast soccer, baseball, softball, volleyball, basketball here, men's and women's, for all of those. And generally speaking, we focus on the game itself. But when we started talking about doing a more extended pregame show, or the pre-pregame show, the idea was to really make it more fun, make it looser. We wanted to show a little bit of the behind the scenes of what goes on as you're getting ready for a broadcast. And so we did one of those in February. We had a lot of fun. They call it the pre-pregame show. And we used the live view as our primary camera, our camera system. So we had a mobile operator outside during all the pregame festivities. You had the cheerleaders and the band going, and all the people tailgating outside the arena. So the camera was actually able to weave through all of that, and you can see just all of that atmosphere. And then we jump back into for a segment inside the arena, and that was a wired camera, but just having that ability to bounce back and forth, we talked about wanting to capture that experience, what that feels like outside, for years really, and it wasn't until we were able to get a live view that became a practical solution for us.
So obviously the challenges that are coming up this fall for all universities and institutions trying to produce sports content are quite extreme. And what kind of vision do you see for live going forward? How are you going to try and pull the students into the games more and get them involved, assuming that you are able to have those games?
Yeah, that's a big if. We're still waiting to find out for sure if there will be games this fall, but eventually they'll happen. We know that eventually there will be games again, whether it's this fall or the winter. And so what we're really trying to think about is, it's almost, in a lot of ways, it's the same thing we've been doing. We tried it when we were streaming live sports. You're trying to take that experience, extend it out to this broader viewership. And that's one of the things that's kind of unique about Grand Canyon University is we have a campus here in Phoenix, Arizona, with about 24,000 students typically, but we also have close to 70,000 online students, and so we have this huge body of students that really does identify with the university and its athletic programs, and so we try to give them as much of an equal experience as our traditional ground campus students, and let them be a fan, let them be connected. And so it's really all about capturing what's going on and sharing that out to this broader group of people.
And now it sounds like your on-campus students and the off-campus students are going to have a very similar online experience. So really great stuff that you guys are doing there at GCU. Stephen, thank you so much for joining us this evening here on the LiveU Sports Show.
Yeah, thank you. It was fun.
And you know what that sound means? It's time for our remotely interesting segment. Joining us tonight is our VP of Engineering all the way from South Jersey, Dan Pozarski. Dan, welcome back to the LiveView Sports Show.
Thanks for having me back.
So Dan, can you walk us through the elements that make up the LRT protocol?
Absolutely. There's some key ingredients there that make it a very resilient protocol. The first of which is packet reordering. Anytime we send packets over many different connections, the way bonding works, or even sometimes when you send packets over a single connection, they're going to arrive on the far side out of order, and you need a way to put those packets back in order so that it turns back into a video and audio stream that makes sense to end users and to our decode software. So that's resiliency technique number one. Resiliency technique number two is what we call acknowledgement and resend. It's the ability to tell that some packets didn't arrive. Since the underlying packet format we're using doesn't guarantee packet arrival, we do it at our protocol layer to ensure that all the packets have arrived, and if some haven't arrived and we have enough time in the latency between glass to glass, we can ask for that packet again. The third, and maybe the most important one, is a pretty fancy mathematical technique called forward error correction. It's the ability to send not 100% redundant data, but some lower percentage redundant data that can be used mathematically to reconstruct missing data. So let's say we send 15% more data than the actual video and audio stream, and some of that video and audio stream doesn't arrive. We can use that 15% data plus the data that did arrive to mathematically reconstruct the missing data. It's exactly the way RAID works in hard drives for those older computing people that remember RAID drives when we didn't store everything in the cloud. The last component that's important is called adaptive bitrate, what we sometimes internally call tight encoder coupling. And that's the ability of the streaming software to inform the encoder of how much bitrate we can actually send. So that way, if the network is only able to deliver 3 megabits per second, but the encoder is making 4 megabits per second, we don't make more video than the streamer can send. We only make the 3 megabits per second, and that's exactly what we send.
So how does this differentiate from other IP transport protocols, say something like SRT?
It's a good question. So obviously the key element that LRT uses that many other protocols, most other protocols don't use, is network bonding, using many IP connections all at the same time to make a more resilient stream. That's something the majority of resiliency protocols you might be reading right now haven't yet supported. But there are other elements as well. For one example, SRT doesn't use forward error correction and LRT does. Now some other protocols may also use forward error correction as part of SMPTE 2022-7, for example. But it shows you how each protocol makes its own choices about different resiliency techniques to include. In our case with LRT, we've included every resiliency technique we think is important, especially for LTE networks.
So Dan, if a customer has Ethernet available to them, as many sports customers do, why would they still want to use a protocol like LRT?
So there's a few key reasons why you would still want to use LRT. One is that you get the advantage of IP bonding as a backup, even if it's not your primary path. There's a setting on the units called least cost bonding that lets you use Ethernet as the primary path and will only use LTE networks if that Ethernet should fail. So it gives you an automatic failover in the event that your primary network connection fails. Some other advantages are that even over Ethernet, LRT uses all of its resiliency techniques, like forward error correction, to ensure that packets get through. So again, if you have a problem with your Ethernet connection, that stream is still going to be delivered. The last reason is security. So using a end-to-end protocol like ours and a closed ecosystem like ours, you have higher security than if you're using something that's a well-known and open source protocol on the internet.
So one area of concern for sports broadcasters, Dan, is obviously low performance in bandwidth challenged situations, or where we might see a lot of network fluctuation. How does LRT handle that, and what advantages do you have as a result of using this protocol?
So everything we just talked about are resiliency techniques, from IP bonding to forward error correction to acknowledgements and resends. And you're always getting the advantage of all that resiliency whenever you're using LRT. But the setting that we give control to the end user for to adjust when you're in a challenging scenario is the glass-to-glass latency. And it's a key thing to note that in the LiveView ecosystem, when you're inputting latency to the unit, that is true glass-to-glass. From the camera to where you're seeing that video come out on the far side, that's a true latency of end-to-end. The higher you set that latency number, the more resiliency we can use. We can use way more resends. We can use higher numbers for forward error correction. We can even use a deeper jitter buffer. all things to help try to get packets through even under challenging scenarios. So where you can tolerate it, or if you're in a situation that absolutely demands it, increase that latency on your unit. And if you're in some sort of controlled environment, very good LTE networks or LAN, and you don't think you have that need, then you can lower that latency to the lowest number you would like.
So Dan, speaking of timing and latency, let's say I had multiple different LU600 backpacks in the field doing an at-home production. How would those arrive back at the studio all in sync with each other?
That's actually a technique we call live view precision timing, and it's built into the protocol we've been talking about here, LRT. In the last answer, I talked a little bit about glass-to-glass delay and how when you input latency into the live view ecosystem, we try to make that true glass-to-glass from the camera to the output. So precision timing works by having that latency be extremely accurate, single-digit milliseconds accurate in terms of what the actual latency measured from the input to the output really is, including measuring the network leg extremely accurately. So multiple units, all set to the same delay, are all using this internal algorithm called precision timing to measure that glass-to-glass latency, and doing so within the millisecond of each other. On the far side, you end up with frames that come out also synchronized to within the millisecond of each other, departing from that decode server on the far side.
Awesome. And Dan, what does all of this mean with the brand new LU800? We're all very excited about this here at LiveView. How does LRT and precision timing play into the LU800?
Absolutely. So the LU800 is a very advanced machine. By encoding all four inputs in the same machine, we're able to improve that precision timing down to a 0 millisecond difference on the output on the far side. That's improvement number one. But another key thing to understand is that you've got four inputs going into a single machine. So for example, one Ethernet connection can serve all four streams. But the four streams are handled in some ways independently. Where it's important, they're handled as a single stream, for instance, the alignment of the frames. But where it's important for things like ensuring packet delivery and ensuring that all four streams get to the far side, they're actually handled independently, and it's expansion on the LRT protocol to be able to handle all four streams. So it's a very advanced technique, specifically a great fit for that type of at-home production where you would be using multiple inputs to the same machine.
Awesome. Dan, thank you so much for joining us this evening on the LiveView Sports Show. Looking forward to seeing you soon.
Thank you very much. I always appreciate being here.
And that's going to do it for this edition of the LiveView Sports Show. Be sure to like and subscribe to our Facebook and YouTube pages for all of the latest great video content that we're making here at LiveView TV. On behalf of everyone here at LiveView, thanks for joining us. I'm Chris Perry. Good night.